our next video on solutions is called molality. And when we talk about molality, we want to make sure that we understand that it's not the same thing as molarity. When we talk about molarity, remember that's the that's the big M, and that is moles of solute over liters of the solution. Molality, really the only difference is that little L right there. So instead of molarity, it is molality. And there's really only one specific time that we're going to use molality. So after the following lesson, after this one, we're going to learn when we actually use molality in chemistry. So today we're going to talk about what molality is, and then in the next couple of lessons we're going to be actually using the molality to solve some problems. So first of all, molality. Notice again how it's different from molarity. Molarity, we use a big M. With molality, we use a small m. So if you want to say that the concentration of a solution is 1.25 molar, you would say 1.25 big M. If you want to say a solution has a concentration of 1.25 molal, 1.25 little m. Big difference between the two. So what is the molality? It is the concentration of a solution, so similar to molarity. It's another way to measure concentration, and it's defined as the moles of the solute per the kilograms of the solvent. So you'll notice one thing that's the same. In molarity and in molality, the top part of the equation has moles of the solute. Okay, that doesn't change. What's different between molality and molarity is the denominator, the bottom of our fraction. In molarity, remember, it's liters of solution, and in here, in molality, it is the kilograms of the solvent. So notice that little m, molality, is equal to moles over kilograms. And when we talk about the solvent, normally we're talking about water. Okay, water is we call that the universal solvent. It'll dissolve a lot of things, not everything though. So a lot of times when we're talking about the kilograms of the solvent, what we're really talking about is basically the mass, kilograms, of water that make up the solution. So in a problem such as this, we've got 0.2 moles of sodium hydroxide. It's mixed with 0.5 kilograms of water, and they want us to find the molality. So as we just saw, molality, little m, is equal to moles of solute over the kilograms of the solvent. So we've already got moles. That's our sodium hydroxide. So little m is going to equal 0.200 moles over 0.500 kilograms. So we simply put those two numbers into our calculator, 0.200 divided by 0.500, and we get an answer of 0.4 on the calculator, but then we've got 3 significant digits here, 3 here, so we need to add 2 more zeros onto the end of that. And then we can write our answer as 0.400, that's a 4, little m, and that stands for molality, or 0.400 moles over kilograms. Either of those two ways is perfectly acceptable. Okay? So just like with molarity, let's make sure we remember this, that molarity, if we write molarity, if the answer was 0.4 molarity, you would write 0.4 big M, or 0.400 moles per liter. With molality, it's 0.400 little m, or 0.400 moles per kilogram. Now, if something has a molality of 0.400, does that mean it has a molarity of 0.400? And the answer is no. Okay, molarity and molality are not the same thing. The mass of the solvent, the kilograms of the solvent, the water, most times isn't remotely close to the liters of the solution. So just because the molality is this doesn't mean that the molarity is also the same thing. Okay, so here's another example. It says calculate the molality of a solution that contains 24.4 grams of nitric acid in 198 grams of water. So again, I'm seeing molality there. So I'm thinking molality equals moles of the solute divided by the kilograms of the solvent. So in this case, I've got 24.4 grams of nitric acid, but it needs to be in moles. So the first thing I need to do is I need to take my 24.4 grams, and then I have to think about what the formula is for nitric acid. Nitric acid does not have hydro in front, so that means it comes from our polyatomic ions. Nitric comes from nitrate. Nitrate is NO3 minus, so we need one hydrogen to cancel out that minus charge. So it's HNO3. And so then we go to the periodic table. The molar mass of nitric acid is going to be 1 plus 14 plus 48 for my 3 oxygens. So that equals 63 grams in 1 mole. So now I'm going to take 24.4, divide it by 63, and that equals 0.387 moles. Okay, so that is my moles of my solute. So I'm going to go 0.387 moles on the top. And then on the bottom, I need my kilograms of my solvent. Here's my grams of my solvent. Remember, water is the solvent. But to convert from grams to kilograms, I need to move the decimal point 3 spaces to the left. So it's 0.198 kilograms. So then I just take my 0.387, I divide it by 0.198, and I get a molality of 1.96 little m. Okay, here's a second example, or a third example, excuse me. It says if a solution has a molality of 1.23 and contains 12.4 grams of calcium hydroxide, what mass of water in kilograms is present in the solution? So when we think about our equation, molality equals moles over kilograms. In this case, they're giving us the molality, that's this. They're giving us the grams of calcium hydroxide, which we know, like in the previous problem, we can convert to moles. So if we know the molality and we know the moles, we can find the kilograms. Now, first of all, before we start putting numbers in there, let's rearrange our equation to get kilograms by itself. And the easiest way to do that is basically to switch the molality and the kilograms. You multiply both sides by kilograms, and then you divide both sides by the molality. So the equation becomes kilograms equals the moles over the molality. So the molality we just saw up top here is 1.23, and again that's moles per kilogram, or excuse me, no, that's wrong, sorry. Kilograms equals moles over molality. The molality goes on the bottom, 1.23 moles per kilogram. And you notice that I recognize my mistake because I was using my units. When I put 1.23 on the top, it was going to be moles on top and kilograms on the bottom. And I thought, wait a minute, it can't be that way. Kilograms have to go on the top. So when you put 1.23 molality on the bottom, then the kilograms end up on the top like they should be. Now we just need the moles of calcium hydroxide. So I'm going to take my 12.4 grams of CaOH2. I'm going to figure out the mass of it. So calcium is 40.1 plus 2 oxygens is 32 plus 2 hydrogens is 74.1. So 74.1 grams, 1 mole, 12.4 divided by 74.1 equals 0.167 moles. And so that's what I'm going to put here for my moles, 0.167 moles. Then we can see our moles are going to cancel, and all we have left is kilograms. So 0.167 divided by 1.23, I get an answer of 0.136 kg kilograms. Okay, and that's our final answer. They want the answer in kilograms, so we give them the answer in kilograms, 1.136. If they had asked for the answer in grams, what we could do is we could just move this decimal point 3 spaces to the right, and that would give us 136 grams. But they don't ask for that, so we leave it as 0.136 kilograms. All right, one more here, and then we are done with this. It says, what mass in grams of calcium nitrate is needed to create a 1.25 molal solution that contains 87 kilograms of water? So again, in this case, let's think about our original equation. Molality equals moles over kilograms. What information are they giving us? Okay, this is a good point where you can stop the video and try to do this yourself and see if you can figure it out. Okay, let's see if we know this. 1.25 molality, that's going to go here. 87 kilograms of water, that's going to go here. And what are we missing? We're missing the moles. So let's find moles. So we're going to multiply both sides by kilograms. So we're going to have moles are equal to the molality times the kilograms. So the molality, like we said, was 1.25 little m, and again, that's moles per kilogram, and we're going to times that by our kilograms, 87.0 kilograms. 1.25 divided by 87 equals 109 moles, because our kilograms cancel. And now they want the mass, though, in grams of calcium nitrate. So we need to take our 109 moles, and we can say 1 mole on the bottom, and now we need the molar mass of calcium nitrate on the top. To know the molar mass of calcium nitrate, we need the formula for it. So calcium is +2, nitrate's -1, so it's going to be CaNO3, 2. So calcium is 40.1 plus 2 nitrogens, that's 28, plus 6 oxygens, that's 96. That is 164.1 grams. We're going to multiply that by 109 moles. Moles cancel. And holy cow, we get a real large number. We're going to round that to 3 significant figures because these both have 3 significant figures. So that's going to be 17900, 17,900 grams of calcium nitrate is our final answer. Okay, so just a quick review of all of the different ways that you can measure the concentration of a solution. One of the ways, as we learned, is mole fraction. So that's the moles of whatever it is, moles of A over the total moles. We learned that one with the gases. And then we also learned about percent by mass or percent composition. That is the mass of A, whatever they're asking you about, again, over the total mass. Then to get a percent, you multiply by 100. So that was our second way. Our third way that we learned about expressing concentration is molarity. And molarity, moles of solute over liters of the solution. And then the one we just learned today is the molality of a solution, which is equal to, again, the moles of the solute on the top, and then the kilograms of the solvent on the bottom. Okay, all 4 of those you should be familiar with. You should be able to find any part of it, and that is a good introduction to all of the 4 different types of concentration.